You're watching Comets and Cogs.
Welcome back to Comets and Cogs. I'm Logan.
And I'm Jonah.
And today we're going to start a new episode. And this will be our final episode of Comets and Cogs. We are really sad to see this podcast end, but luckily we're going to end off of a bang. And we will deeply miss us making podcasts for you. You have anything else to say, Jonah?
Yes. We wanted to thank you all for showing your support during these past few weeks. Every single view in our episodes just means a lot to us.
It really does.
But please do not let this be like, oh no, the podcast is gone forever. No. All of the episodes that we've recorded on Spotify and YouTube will still be available to watch. So don't worry, you'll be able to catch up on any episodes you might have missed, or just, enjoy the episodes again.
So like I said, this episode's going to be a banger. So today we're going to be talking about how robots can explore gas giants and other terrarian planets. Terrestrial planets.
So this episode will be split into 3 segments. First, we'll talk about the definition of non-terrestrial planets. Second, we'll talk about the dangers of exploring non-terrestrial planets. And then finally, we will discuss our opinions as to how robots could explore these non-terrestrial planets.
So anyway, let's get into that.
To start, we will define non-terrestrial planets. Logan, do you want to start us off?
So what we've come up with a non-terrestrial planet is so terrestrial planets are planets that are mostly solid, kind of like Earth. It has a lot of water, but it's 30% land. Ice giants, which is one non-terrestrial planet, is mostly water. It's about 80% to 90% water or ice. And similar thing with gas. Yeah, you're right. Similar thing with gas giants. It's 90% gas or 80% gas, and it's has a solid core.
So essentially, all the terrestrial planets are ones that are comprised of mainly solid rock lands, which are the first 4 planets closest to the sun, those being Mercury, Venus, Earth, and Mars. And all the non-terrestrial planets, which are made of gas or ice, are the farthest from the sun: Jupiter, Saturn, Uranus, and Neptune. The non-terrestrial planets are split into 2 groups: the gas giants and the ice giants. First, we'll talk about the gas giants. Now, Logan, I'm pretty sure that you already know a really, really big example of a gas giant.
So yeah, probably the most popular gas giant is Jupiter. There's also Saturn. Well, both of them are really popular planets. I guess all the planets are pretty popular.
Yeah, I guess. But out of all,
Jupiter is very famous.
Yeah, out of the 2 gas giants, Jupiter, the biggest planet in the entire solar system, is by far the most iconic, and we'll talk more about it later. The other gas giant is Saturn, the ringed planet, which is definitely not as big as Jupiter, but it's got rings, so it still looks cool.
Yeah. And then there's the 2 ice giants, Uranus and Neptune.
Which are ice giants because they're a million bajillion miles from the sun, so you can imagine how cold it gets.
Yeah, it's very cold.
Imagine Antarctica, the lowest temperature of Antarctica times 4. That's how cold it is. Step 1 foot on it without proper warmth and immediate ice statue. Just no other way of putting it. Immediate ice statue.
So anyways, let's talk about the dangers of these new non-terrestrial planets.
So, some of the dangers of non-terrestrial planets. First up, let's talk about Jupiter. Jupiter, because it's a gas giant, it has a really, really strong gravitational pull. And it's essentially what it sounds like. It pulls objects into its gravitational field and essentially just destroys them.
Yeah, and it pulls the objects away that might hit Earth towards it, or just pulls it off course.
Yeah, Jupiter's gravitational pull is strong enough to pull in asteroids that might be heading to Earth, or even yank planets out of orbit, so they can destroy it. Fortunately though, Jupiter's pull isn't strong enough to just yank all the other planets in the Milky Way out of orbit, so we don't need to worry about that.
Yeah, but if it's like a smaller, like smaller kind of planet, like an asteroid-sized planet, it will knock that off course.
Yeah.
And another dangerous thing about Jupiter is the surface of it, which can have wind speeds of up to 900 miles per hour.
Oof. Bro, just imagine a wind turbine with too much voltage blowing at you. Just, this would be the turbine, this would be you just flying.
That is true.
That's how strong
And
Jupiter is.
similar with Saturn, Saturn also has these similar issues, but they're not as intense as Jupiter because Jupiter has a low... Oh yeah, because Jupiter has a low atmospheric pressure, so it allows these wind speeds to get super high. Saturn has a little bit higher atmospheric pressure, so it's not 900 miles per hour winds.
Okay. And of course, the main thing, you can't walk on Jupiter. Like, you can't walk on Jupiter or Saturn. It is not possible. They're made of just gas, no solids. It's not like Mercury, Venus, Earth, or Mars where you can just walk on it like you walk on the ground. No.
Yeah, so Jupiter's gravity is about like 2 times as much as it is on Earth, so it'll be very hard to walk around, and if you fall, you're probably not going to get back up.
Yeah. Anyways, now we're going to discuss... Wait, pause. I almost forgot about the ice giants.
So first, so yeah, they're very similar in nature, but we'll talk about Neptune because they're basically the same. So Neptune is, as you guess, very, very, very cold, and similar to its atmosphere, it has like an atmosphere of hydrogen and nitrogen, like a very, very, very dense atmosphere, which keeps in like it like traps in heat, but it's so it can have liquid oceans, but the oceans are just like very cold, like liquid nitrogen oceans.
Yeah. So it has no heat, no light, and extremely cold winds. So once again, immediate ice statue.
Yeah, so Neptune is very unique where it can have heat to like have liquids on the planet, but it's still very cold. It's a very interesting planet. And I don't know if we're going to be able to talk about everything about Neptune in this episode. It's the last one.
Yeah. Uranus is pretty similar, but men do not judge my pronunciation. Anyways, that planet is pretty similar. Once again, it's really far from the sun, but I could imagine that it gets like 1% more heat. It's closer to the sun only by a little bit. It like gets 1% more heat. So it's not like by going to Uranus you'd be feeling a bit warmer. There would barely be a change, like barely.
Also, unrelated fun fact, like Uranus is like, you know how like the Earth has north and south poles? Well, for Uranus, those poles are flipped to west and east, so it's sideways.
Yeah. So yeah, you got Uranus, and you.
Okay, so our last topic will be about how we think robots will be able to explore these non-terrestrial planets. So, first of all, what do you think? What's your opinion?
Well, based on what we know about gas giant, I can't really think of any sort of specific way to explore gas giants like Jupiter. All I know is they're gonna need to find some way for the robots to like counter the gravitational pull.
Yeah, so there's this unique machine. It's called a gyrosphere. I think it's what it's called. Not 100% sure. But it's basically a machine that measures if it turns, it measures the distance, and if you have thrusters hardware, if you have thrusters connected to the gyrosphere, it can check, it could check the distance and adjust for it. So let's say it turned that way, the thruster will check, or the gyrosphere will check that distance, and then make the thruster turn the other way so it's stable.
So you're saying that you could give robots thrusters that detect changes in gravity and adapt to them?
Yeah, so if it's really windy and it's getting blown this way, the gyrosphere can detect how much it's turned and use the appropriate amount of thrust on the other, the opposite thruster to push it back into place so it's centered and it'll land smoothly.
Interesting. I feel like that's kind of something that we could, that could probably be made during this time. I think technology is at that point. I'm not 100% sure.
It probably has to be more advanced because 900 mile per hour wind speeds are gonna knock it around very much, a lot.
Yeah. And as far as the ice giants, you gotta find a way to resist the cold. The only real thing I can think about, you gotta find a way to resist the cold. Because if the robot does not have any sort of protection from the cold, as soon as it touches down Neptune, its systems are gonna freeze, the body's gonna freeze, it won't be able to move. Immediate robot statue. So how could they possibly counter the low temperatures? Is there maybe there's some sort of metal alloy now
So yeah,
is super freeze resistant, freeze proof.
So yeah, all rovers are built with freeze protection, but no rovers have been built to withstand temperatures of Uranus and Neptune, because those are negative 400 degrees. They're very, very cold, and as far as I'm sure, there's no easily accessible metal or alloy or whatever material that could protect it from that temperature.
Yeah, that is true. And also, think about how far Neptune and Uranus are from Earth. Since they're super far from the sun, then you need a super powerful rocket or other form of space transportation to get there. I'm pretty sure that's a thing now, but I think that they could probably go ahead and incorporate robots into it. I don't know if they're doing that now, but I feel like that's something that they could do.
So yeah, if you're taking a rocket directly to Neptune, it's going to require a big rocket and a lot of fuel. But rovers and probes, or not rovers, probes have made it to Jupiter and past the solar system, except it takes, the one I read about took 15 years to get to Jupiter because they used gravitational pull to off of the Earth to slingshot it to Jupiter, and it took a really long time. And then the gravitational pull of Jupiter slingshotted it out the solar system.
Wait, so you're saying that Jupiter's gravitational pull can pull stuff in, but also launch them out as if it were a t-shirt cannon or something?
Yeah, if it has the correct trajectory, it can it could get launched in, and then but the force of the launch can make it shift so it's not in a stable orbit, so it'll get launched back out.
We probably should put that, but it's whatever. It's still in here.
What?
So yeah, there's a lot to think about in terms of getting robots onto non-terrestrial planets. But now, guys, I see nothing else to do than to conclude this episode.
So let's summarize what we talked about. So first, we talked about what defines a non-terrestrial planet. We talked about what are the dangers of non-terrestrial planets, and we talked about how we think robots could be able to get to one.
Once again, non-terrestrial planets are like a million times more complicated than the rocky terrestrial planets, such
Than
as
like
our dear
Mars.
home Earth.
Or like the moon.
Yeah, but technology is improving at a rapid rate, guys, and I'm certain that there will be some point, maybe in the near future, that we will be able to get robots and potentially even humans onto like gas giants and ice giants, so we can learn a lot more about them.
So yeah, that'll conclude today's episode and our final episode of Comets and Cogs.
Once again, thank you all for listening over these past few weeks. All of the views of our episodes and the support that you show means a whole lot to us. But for the last time,
I'm Logan.
and I'm Jonah.
Last thing on. See ya.